So, could someone confirm that if my screen is visible?
Yes, ma'am.
Yes,
Okay, thank
yes.
you, thank you. So, good evening, everyone. My name is Chaitra Borkar, a PhD research student from IIT Delhi, and I welcome you all to the second live session of NPTEL course Basic Environmental Engineering and Pollution Abatement, which is instructed by Professor Prasenjit Mondal from Department of Chemical Engineering, IIT Roorkee. So to reiterate that this session will be conducted every week on Saturday from 3 to 5 p.m. and the live session link has been shared with you all. The live session is recorded and the videos will be made available to you from our YouTube channel. And let's start with the overview of lectures 6 to 9 conducted in the week 2. So, the lecture 6 was all about pollution types and its sources. So, pollution types can be in the form of water pollution, air pollution, soil pollution, and the polluted types can be on the basis of their mode of generation, which can be natural sources or can be man-made sources. And these pollutant types can be of solid, liquid, or gaseous form. Next, the pathway of pollutants is that when a pollutant is generated from its source and then it's introduced into the environment, and how it reaches the organism is the pathway of the pollutant. Next, the sources of pollution and pollutants can be of two types, which is a point source, which is a defined source. You can define that source that yes, you can pinpoint to it that yes, this is the source from where the pollution is being generated, and a non-point source, which is also a diffuse source. So you cannot tell what is the exact source of your pollutant. For example, when the rainwater washes away the pollutants either from the soil or it can be through or it can be a sewage. So when it get mixed with the river water or surface water, you cannot pinpoint to a particular source of pollution. Next, the pollution can be in some way reduced by these four modes, which is dispersion, dilution, deposition, or degradation. So, dispersion is as the name suggests, that the spreading of these contaminants into the atmosphere. Dilution is that because because of the mixing of these contaminants into the atmosphere, but they are in the low concentration as they move away from the source of pollution, so it gets diluted. Deposition, it may get deposited in some area so that the uh, environment is free from them, and degradation is that it breaks down into simpler substances. Water pollution. Water pollution can be through either the industrial waste, which is there, the effluents which are being let into the surface water. It can also affect the groundwater. Then there is water pollution through domestic waste, the sewage water, which is let into the surface water. Then water pollution can be through the fertilizer runoff. Next, the air pollution. Air pollution is most. Please mute yourselves, please. So the air pollution can be through combustion of fuel, which is a major source of pollution in the atmosphere. So air pollution through combustion, it can generate oxides of carbon, oxides of nitrogen, it can generate oxides of sulfur, and it can generate particulate matter, which is a large form of irritant and can cause a lot of problem with our respiratory system. And then there are other metals which can be suspended into there, such as lead. Next is soil pollution. So soil pollution can be through the deposition of waste into the soil, or and a little bit of water pollution is linked to soil pollution in the way that the groundwater can also or the landfill leachates can also be are a component of soil. So they can also degrade the soil in that manner. And the pollution of industries, so the industries also do generate a lot of waste that are emitted into the atmosphere. It can be emitted into groundwater, sorry, it can be emitted into the surface water, it can be emitted into the soil as well. And one more source is noise pollution. So noise pollution can be generates when a lot of when sounds which are above the permissible or audible levels are generated. So that can also be a nuisance for the environment and the organisms. So next, lecture 7 was about the pollution and its impacts or consequences. So water pollution uh, uh, can impact the physical aspects, the chemical aspects, the biochemical aspects, and the microbiological aspects of water. So physical aspects can be about its how the water looks like. Is it dirty? Is it clear? Its viscosity. They're the physical properties. The chemical aspects is what kind of chemicals are present in water. The biochemical aspect can be the dissolved oxygen in it, can be the biochemical oxygen demand or the chemical oxygen demand. So biochemical oxygen demand is the amount of oxygen required by the microorganisms present in the water, which process the organic content. So they consume the organic content. So that is the biochemical oxygen demand. And the chemical oxygen demand is the oxygen required to oxidize the organic content in the oxidizable organic content present in the water. The microbiological aspects can be the microbes which are present in the water. So, as I discussed the biochemical oxygen demand, so there is a term called dissolved oxygen. So, to sustain the aquatic life, the dissolved oxygen is required. So, the oxygen which is dissolved in the water. The impact of air pollution on the on the human species and the other species is such that these for example, carbon monoxide. Carbon monoxide, as we know, is a harmful gas for as it mixes with our blood and reduces the tendency of oxygen being circulated in our body. It can lead to asphyxiation, and there is the harmful effect of SOx. It can affect our respiratory system. The same goes for NOx. It can react with volatile organic compounds and can also lead to degradation of ozone. And then there are particulate matters. So particulate matters of the size from 2 to 4 micrometer are considered harmful as they deposit into our lungs. So they are also causing a lot of problem with our respiratory system. And heavy metals such as lead, when suspended in air, they can also lead to lung failure, kidney failure. Next, soil pollution. Soil pollution, impact of soil pollution is such that it can lead to degradation of the nutrients in the soil, and so that the vegetation is not allowed to be grown. Next, the impact of noise pollution can be to our heart. If a lot of noise is created, the heart of the human species are affected. It can lead to a nervous breakdown as well. Lastly, the ozone layer depletion and global warming was discussed. So, ozone layer depletion is the result of these greenhouse gases. Is the result of this greenhouse gases, which may resulting in the depletion of ozone layer. So, when uh, the uh, as I gave the example of NOx, it can react with the, as I gave the example of NOx, there is also a chlorofluorocarbons which are responsible for the ozone layer, which is present in the stratosphere. So when it gets depleted because of the reaction with the chlorofluorocarbons emitted from, it was earlier being used in the coolants of refrigerators and air conditioners, so it gets emitted into the environment, and then it reacts with ozone, and the ozone layer, it gets depleted. So because of that, harmful radiations such as UV rays can reach the earth. But there are certain greenhouse gases. So greenhouse gases are those which absorb the heat, which is reflected by the earth. So when the radiations reach the earth from sun, they can be reflected from the earth. So when they are reflected, these greenhouse gases absorb the heat from those reflections, and because of that, the atmosphere becomes hotter. So if this cycle is repeated again and again, and there is no check on the greenhouse gases which are present in the atmosphere, it can lead to the excess of it can lead to global warming. So next was lecture 8. Lecture 8 was about the transmission of pollutants in the environment. So transmission of pollutants in the environment can be by two modes, which is firstly diffusion, and the next is advection. So diffusion is basically dependent on the difference in the concentration in the region, and advection can be through the bulk flow of the wind. So these two are the modes, and next, the atmospheric stability of the environment was discussed, which is measured through the lapse rate. So lapse rate is basically the change in temperature with the vertical height. So the atmospheric stability is the tendency to resist the vertical motion of a parcel of air. So if the atmosphere, it can be considered unstable if there is a vertical motion. It can be considered stable when there is no vertical motion, and when the it can be considered stable when the atmosphere resists the vertical motion, and it is considered neutral uh, when the forces are balanced with each other. So. These are the three types, and they are measured in the form of lapse rates. There is a dry adiabatic lapse rate and there's a moist adiabatic lapse rate. So if your atmospheric lapse rate or the environmental lapse rate is greater than the dry adiabatic lapse rate, so it is considered an unstable environment. If it is less than the diabetic lapse rate, it is considered the stable environment. If it is equal to the diabetic lapse rate, it is called a neutral environment. So next, the flue gases which are emitted from the stacks of the industries, they also contain a lot of pollutants, and the plume patterns. So the pattern in which the flue gases flow out from the stack can be of the form of coning, looping, fanning, fumigation, and lofting, which have been discussed based on their relation with the diabetic lapse rate. So, according to that, fumigation and looping are considered the most harmful in that sense. Next, the point source Gaussian plume model was discussed. So, how the pollutants are distributed when they are emitted from the stack. So, the basic assumption of the most basic assumption of this model is that the pollutants are distributed in a Gaussian form. So, in this figure, as you can see, there is a normal or Gaussian distribution of the pollutants. This is the x-axis, which is the distance away from the star. This is the y-axis, which is distance away from the center line, plume center line, and this is the z-axis, which is the vertical height. So, in terms of the stack height, so the effective stack height is the sum of actual height of the stack and the plume rise. So, plume rise is the height of the plume from the point it is actually emitted from the stack. So it is basically a virtual point source. Next, in lecture 9, the continuation of transmission of pollutants was discussed. So, in lecture 8, it was all about the air pollution. Lecture 9 was all about water pollution. So, the transmission in water, so water can be of two types: groundwater and source water, surface water. So, the transmission to the groundwater can be through the fertilizer runoff, the landfill leachates. The surface water can be through contamination in surface water can be through the deposition of sewage. Next, the aquifers were discussed. So aquifers are basically the solids such as rocks or sediments which hold the water. Next, Darcy's law was discussed, which basically is about the effect of dispersive mixing of contaminants. So, which gives the relation such as the uh, that the gradient that the gradient of concentrate that the gradient of uh, the two the gradient of two water groundwater sources is basically relevant is basically proportional to the velocity of groundwater. So next was chemical retardation. So, because of these aquifers, the contaminants can be absorbed into them, and this can lead to the retardation of these chemical contaminants, and that is basically the chemical retardation factor. So, if there is more absorption into the porous solids, so the retardation factor increases. Next was transmission of surface water contaminants. Uh, so, uh, so there is a relation between the rate of deficit, which is equal to the rate of deoxygenation and rate of aeration. So the transmission of surface water contaminants here you can see in the image as well. So uh, uh, this is some river this is river water which is not being contaminated yet. Now there is a sewage source or a pollution source which emits the pollution into this water body. So at the before this emission point, we see that the dissolved oxygen is at a saturation level, and the BOD here. Please mute yourselves. And the BOD here is very less. And when these contaminants are then emitted, the BOD level rises, and the please mute yourselves. I request you to please mute yourselves. This dissolved oxygen decreases because as the contaminants are increases, the microbes present in the water they need oxygen so as to process this organic content. So the dissolved oxygen then decreases, and it can decrease to a critical point, which is the lowest oxygen amount, which is required to sustain the aquatic life, and it can decrease below that as well, which should not happen. And this can be kept in check because of the rate of re-aeration. So re-aeration is that because there is an equilibrium generated with the atmosphere and the water. So the oxygen present in the atmosphere can absorb into the liquid because there is a deficit being created here. So the oxygen from the environment can also absorb into the water. So because of that re-aeration, which will basically be greater, which uh, uh, can be greater than the rate of deoxygenation, the deficit starts to decrease and the dissolved oxygen starts to increase. Also, the biochemical oxygen demand decreases. Why? Because the organic content is being consumed here. So it can be a coupling effect that BOD is decreasing as well as the re-aeration is happening. So the deficit decreases and the dissolved oxygen increases. So yes, we can say that the rate of deficit here is equal to the rate of deoxygenation when we subtract it from the rate of aeration. So now we come to sample questions of assignment 2. So these we are discussing these questions, and these can help you in solving your the assignment 2 given to you. So we start with the first question. Till this point, does anybody have any doubt? You can ask me.
No, it's okay. You can proceed.
Okay. So I start with the sample questions. So first question is the man-made pollutants are produced through human activities. Identify the activities responsible for man-made pollutants. So as we can see, the man-made pollutants can be of domestic type, the industrial type, as well as the agricultural type. So domestic type can be sewage or the waste generated, organic waste generated, or the dry waste which can be generated. The industrial activities can be the waste generated. So as we discussed, the flue gas stack and the other chemicals which can be generated as waste, and agricultural waste can be the fertilizer runoff or the organic waste which is generated. So yes, all of the above options are correct here. So the next question is the process in which some substances break down by natural processes into different and simpler substances is known as. Can anybody give me the answer for this? Which is the correct answer here?
It's degradation.
Yeah, correct. So degradation is basically the breakdown of a complex substance into simpler substance. Yes, the correct answer is degradation. The next question is for landfill leachates, the typical range of COD milligram per liter for the methanogenic phases. So I'll first discuss with you what is the methanogenic phase. So in the landfills, so what are landfills? Landfills are basically it is the most conventional form of waste management. So the waste, solid waste, or the waste from the domestic areas is being collected into one region, or and it is in that region in one area this all solid waste is deposited. So these are the landfills, which are the huge dumping grounds for waste. So, what is a landfill leachate? So, when because of when the rainwater or any form of water is being introduced into these landfills, so it can the this runoff can go into the soil, and because of this water being present, they can also lead to degradation of this waste. So there are there are four phases in which the degradation can occur. So first is hydrolysis phase, which basically hydrolyzes the waste. Then the acidogenic phase, which then converts the hydrolyzed waste into the volatile fatty acids, and the acetogenic phase, which then converts this volatile fatty acids into uh, acetic acid, and the methanogenic phase, which converts these acetic acid into methane. So all of this process is anaerobic in nature. So in that we know that the answer here is 500 to 4500 ppm or milligram per liter. So, and the average range is about 3000 milligram per liter. So, these are the four phases for anaerobic decomposition, basically. And methanogenic phase is the last phase in that process. So, the next question is find out the most suitable option from the following to explain the consequences of long-term consumption of fluoride contaminated groundwater. So, can you give me the answer for this?
Skeletal fluorosis.
Yes, correct. So, please mute yourselves. As I had discussed in the last session as well, so the fluorine is being introduced in the drinking water or the water we consume. Why? Because a small amount of fluorine is being introduced, less than 1 ppm or 1.5 ppm. So, why? Please mute yourself. Please mute yourselves. I request you to kindly mute yourself.
వాడిని మ్యూట్ లోనే ఉంటారు నాది మ్యూట్ లో లేదు.
Yeah, thank you. So it is being introduced so that the dental health is preserved. But if it increases from a permissible level, or if there is a long-term consumption of this fluorine, it can lead to the degradation of bones, weakening of bones basically, and which is called skeletal fluorosis. So next question is, which of the following option appropriately connects the transmission mechanism with examples of diseases as provided in the table below? So the transmission mechanism for the diseases can be waterborne, water-washed, water-based, and water-related. So can anyone of you tell me what will be the answer for waterborne transmission mechanism?
It's cholera, typhoid, bacillary trachoma.
Okay, yeah, correct. So waterborne transmission mechanism basically that you consume the contaminated water. So yeah, cholera, typhoid, bacillary trachoma, yes, it is the example for waterborne. Can anybody tell me about the water washed one? Somebody else, please.
cholera, typhoid, bacillary trachoma.
No, I'm talking about water washed.
It's the third one,
It is,
trachoma and dysentery.
yes, correct. So water washed is basically it is because of the lack of the sanitary conditions or lack of personal hygiene. So yes, trachoma and dysentery are an example of that. Yes, correct. What can be the example of water based?
Schistosomiasis.
Yes, correct. So schistosomiasis is the example for that. So water-based are basically when you consume the water contaminated by the invertebrate or aquatic organisms present. So schistosomiasis is the example for that. And lastly, the water-related example of diseases can be the option left, which is malaria, yellow fever, or dengue. So water-related are basically when the diseases require a water medium to get spread. So, in case of malaria, as you can we can say that these are vector. So the vector for malaria can be insects or the mosquitoes which are there. So the malaria can be spread through water. So yes, this is the correct option here will be A4, B 3, C 2, and D 1. So yes, the last option here is correct. So next question is, a stable atmosphere will suppress or resist what type of motion? So can anybody give me the answer here?
Vertical motion.
Yes, correct. So as we had discussed before also, the stable atmosphere will be the type which resists the vertical motion, and vertical motion is basically of an air parcel. So it is based on the relative density. So if a parcel of air is hotter than its surrounding, its density will be lower. So it will tend to rise vertically upwards. And if the temperature of the temperature of the parcel of air is colder than its surrounding, it will not tend to rise up because its density will be lower. Uh, its density will be higher, sorry. And the hotter parcel of air will have lower density. Yes. So guess the vertical motion. Next question is, what is the assumption of the point sources Gaussian blue model? So can anyone give me the answer here? What is the correct answer?
D.
No.
Chala check.
Please read the options correctly, carefully.
Option 3.
Yes, correct.
Yes, yes.
So, because in the Gaussian plume model, there are a lot of assumptions which are being made, and which basically includes that the wind speed should be constant and the emission rate also should be constant. So, the first two options are incorrect. But the pollutant should be conservative in the sense that it should not react, so that the amount of pollutant which is in the does not in the atmosphere is not depleted. Its concentration may be different because it is being dispersed, but the amount will remain the same. So yeah, the option three here is correct. So these are the assumptions. So first is pollutants are released from a virtual point source. The emission rate is constant. The advective transport is through the wind, and the dispersive transport follows the Gaussian distribution. The wind speed is constant. The pollutants are released from a virtual point source, which is the same, and the pollutant is conservative. The terrain is flat and there are no obstructions, and the atmospheric stability is uniform. The next question is find out the most suitable option from the following to identify the gases responsible for global warming. So,
All of them.
yeah,
All,
correct. So, all of these are responsible for greenhouse effect and cause the global warming. So, question 9, a phosphorus limited lake with surface area equal to 80 into 10 to power 6 meter square is fed by a 28 meter cube per second stream that has a phosphorus concentration of 0.01 milligram per liter. In addition, effluent from a point source adds zero point 0.9 gram per second of phosphorus. The phosphorus settling rate is estimated as 10 meter per year. Estimate the, uh, please mute yourselves, estimate the average total phosphorus concentration. So, I'll just discuss with you the answer for this and first give you the logic behind this solution. So here it is written that phosphorus limited lake with surface area is fed by a stream. So we can say that this is a lake with some surface area and it is that has a and is fed by a stream. So there is a stream uh, which has phosphorus concentration 0.01 milligram per liter, and the flow rate of the stream is 28 meter cube per second. So this is C in, this is Q. So and a point source, another point source. So this is S. It also adds to the phosphorus being present, phosphorus which is present in the lake through the stream. So this is zero point 0.9 gram per second. So this is mass flow rate. This is the concentration. This is the concentration of phosphorus in the stream, and this is the mass flow rate of phosphorus being introduced from the point source. And this is the lake which can accumulate the phosphorus in it, and the phosphorus settling rate. So the accumulation rate is 10 meter per year. And so estimate the average total phosphorus concentration. So the relation here will be through the mass balance of phosphorus QC in plus the point source. So here all of these components will have the units gram per second or milligram per second. Okay. So S is equal to, so these are the this is the phosphorate rate of phosphorus coming in, and what will be the out and the accumulation rate. So accumulation will be, so accumulation is given in meter per year, so it is length per second, and we have been given the surface area. So surface area plus the settling rate I am denoting as Vs. So this will give me, the rate of accumulation of phosphorus plus the QC out, and this will also have C out. So here all of these units will be, so this is the unit of volume per time. This will be amount per volume. This is amount per time. This will be, this is area, so length square. This is L length cube per no, this is length, and this is length per time. So this is length cube per time, and this is amount per volume. So this is volume and this is volume, so it gets deducted. So amount per time, and then this is again volume per time, and this is amount per volume. So so the overall unit of this relation will be amount per time or gram per second or milligram per second. So we can see that when we use this relation, so we need C out here. So the average total phosphorus concentration, which will be equal to QC in plus S upon AVS plus Q. So which comes out to be here as, if you see, Q will be 28 meter cube per second, we need to convert it to liters, or we can go for, if it is milligram per liter, we can convert it to milligram per meter cube, because the units need to be consistent. So 28 meter cube per second will be 28,000 liter per second into 0.01 plus, which will give us the uh, concentration in rate of phosphorus in as milligram per liter, and uh, sorry, milligram per second, and this is gram per second, so 0.9 gram per second, so it will be 0.9 into 0.9 into 1000 milligram per second, and next is AVS. So A is here 80 into 10 to power 6 meter square into Vs is 10,000, 10 meter per year. So you need to convert that year to second. So that will be 10 upon. So in 1 year there are 365 days, and 365 days have 24 hours, and 24 hours have 3600 seconds. So we need to convert that. And plus the Q, which is, so here it will be uh, 9 Just a minute. So meter cube. So we need to multiply by 1000. Why? Because we need liter here, and this is uh, no, we don't need that. We can remove that, and the cube will be 28 meter cube per second. Yeah. So this gives you the correct answer. We'll just calculate it once for brevity. So it comes out to be 0.022 milligram per liter. So next question is question 10. Find out the air to fuel ratio, mass by mass, required for complete combustion of a liquid fuel. So the average formula is C7H13 in an internal combustion engine. So here the equation is also given. So C7H13 is reacting with 10.25 moles of O2 and 38.07 moles of N2. So because air to fuel, so air consists of oxygen as well as nitrogen. So it gives you CO2, water, water vapor, and nitrogen. So here we need to find out the air to fuel ratio. So mass by mass. So what is the air required here? So we will we can say that the 10.25 moles of O2. So moles of O2 is given. So we need to get the mass of O2 required. So we will multiply it by the molecular weight. So molecular weight of O2 is 32. And here we have been given 38.07 N2. So how this 38.07 N2 comes out? Can anybody tell me how this 38.007 moles of N2 is being calculated here?
It's a balancing equation.
Yeah, I know it's a balancing equation, but how this moles of N2 are being calculated?
Moles of N2 is the 28 है ना?
Mm, that is molecular
Mole,
weight. I'm talking
yeah,
about moles
molecular
of
weight.
N2. So here to oxidize this fuel, we need 10.25 moles of O2. That is correct. That will be the balancing equation. But how did this mole of N2 come in here? Can you please
Because
mute
the
yourself if
right,
you're not answering? Hello?
yeah, yes, yes. Actually, right, it is right side is also 38.07 N2.
Okay, so I'll start from the big. I'll start from the first point, which is that we need air, obviously, but what component in air is being used to oxidize? It is oxygen, but air also contains nitrogen. So air has 21% O2 and 78% N2, and rest 1% are other gases. So this 78% N2 is also present, but we only require this 21% O2. Means we require this oxygen which is present in air to combust the fuel. But there is also nitrogen being present, and nitrogen, if you see here, is not being reacted. Okay, so the moles of nitrogen which are here are the same moles which are there on the reactant as well as the product side, because they may have considered that the nitrogen is not being oxidized here. So nitrogen is an inert here, if you can say. So how did this nitrogen come in here? So we need uh, so if we need 10.25 moles of O2, so by this relation, that if there is in air, if it is 21% mole percent of O2, so there will also be 78% mole percent of N2. So by this relation, that 10.25 into 78 by 21. So we get that 38.07. So this is the correct answer here. So this 38.07 came from this relation, 10.25 into 78 by 21. There may be a possibility that you're not given this equation altogether. Then how would you know that this is the amount of N2 which is required? Because you are required to find out the air to fuel ratio, not the oxygen to fuel ratio. So if it was given oxygen to fuel ratio, then you would only need 10.25 into 32 in the numerator. But for the air to fuel ratio, you require the amount of air. So it will be 10.25 into 32 plus 38.07 into 28 upon the mass of the fuel. So if we are combusting 1 mole of the fuel, so here only 1 mole of fuel is being combusted. So uh, well, please mute yourselves. 12, which is the molecular weight of carbon, 12 into 7 plus 1, which is molecular weight of hydrogen into 13. So this will give us the answer as 14.37. Okay. So any questions here?
Can you explain COD again, ma'am?
Okay. So
What is COD?
COD is basically,
There is my your question is there. You actually during description you told that COD is the required oxidant in the required oxidant in the water.
no, it is not required. There is a lot of noise behind you.
Okay, madam. Yeah, is it okay?
Yeah, okay. So what I'm saying is, I said that BOD is the oxygen required. I'll differentiate the two for you. So first, BOD is the oxygen required by the microorganisms present in the water to process the organic content. Okay. And
Okay.
COD is the oxygen required to oxidize that oxidizable organic content.
That is only oxidization of organic
Yeah. So
organic
COD is
compound.
basically we do experimentally. So if we oxidize it using, if we take some wastewater and then we put in some oxidizing agents such as, K2CR, so potassium chromate or potassium permanganate. These are oxidizing agents. You can use other oxidizing agents as well so as to oxidize that wastewater. So the oxidize, so through titrations or through other techniques, you can get to know that how much oxygen is required to oxidize that wastewater. Okay, so
Okay, okay.
so that is the way to calculate COD. So it is done experimentally, and BOD is the
No,
amount.
actually,
Yeah, okay. Please go ahead.
Yeah, actually, there is a confusion. Actually, it is to oxidize organic, only organic compound, or total organic or inorganic compound. What is COD? COD is only oxidize the organic compound.
So anything oxidizable present can be, yes, COD. There can be a discrepancy in that. So COD can be for organic waste also and inorganic waste also. Yes, you are correct.
Okay,
So if you are
this
going
is
for
the
total part, so yes, it can be for
yeah, yeah,
organic as well as inorganic. Yes, you are correct.
yeah. This is my question.
Yeah,
This was
correct.
my question.
Yes.
It is only okay. Thank you.
Yeah.
Thank you.
Any other question?
Madam, that last one which you explained, the air to fuel ratio, the
Yes.
last part I could not understand. Can you
Uh,
just once again explain that?
Last part is the nitro. How did the nitrogen come in here?
No, nitrogen, that I understood. The
Okay.
final part.
Okay, the final part. So air to fuel ratio, how did this ratio come in? So by the definition, by the name itself, air to fuel ratio. So how much air is required to combust the fuel? So mass of air upon mass of fuel. So how? So AFR, if I write, this will be mass of air upon mass of fuel. This is mass by mass basis. Okay. If it is mole by mole basis, you do not need any molecular weight. So this is mass by mass of air upon mass of fuel. So here, if we see that for 1 mole of this fuel, we need 10.25 moles of oxygen and these much moles of nitrogen. So effectively, some moles of air is required to combust 1 mole of fuel. So how does that mole of air can be converted to mass? So we need to multiply by the molecular weight. So that's how we will get the mass of air, and the mass of fuel will be the mass of air will be the moles of fuel into the molecular weight. So this is how you get the last part. So this is the moles of oxygen into the molecular weight of oxygen. This is the moles of nitrogen into the molecular weight of nitrogen. This is the basically mass of fuel, which is calculated by there are 12 moles of carbon here, 7 moles of carbon here, and molecular weight is 10, 12, and 13 moles of hydrogen. So it is into the molecular weight, which is 1. So did you get the logic?
Yes, ma'am. Now I understood. Thank you.
Ma'am,
Yes.
uh, regarding this question, there's a similar one in our tutorial.
Mm-hmm.
In that question, the formula is not mentioned. It's just, I've sent it in the chat box. It's just the question without the formula. So
Okay.
are we supposed to assume that 10.25 moles of oxygen
No,
reacts
no,
with
no, no,
same?
no, 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 no. So the average, you have to first. Okay. So in this, there are there are a few levels you need to consider. So I'll just explain it in one go. So it's basically,
Okay.
just a minute. So yeah, first you need to understand that you need oxygen to oxidize the fuel, correct? So first you need to see, this is fuel, I am denoting it as F, plus the oxygen required. And how many moles of this oxygen do you require to combust this fuel? So suppose if it is CH4, okay, this is the most basic methane. So how many moles of oxygen do you require? So the combustion of any fuel leads to carbon dioxide plus water vapor. Correct. So how many moles of oxygen do you need to combust, completely combust methane? Can anybody tell me, or can you tell me?
Yeah, tell me again the question.
Okay, so how many moles of oxygen are required to completely combust methane? Can you balance this equation? Is this equation balanced?
Oh, it will take some time to balance this equation.
No, it will take time,
Ma'am,
but
ma'am,
to what?
2 moles
Of?
oxygen.
Yeah, correct. Yes, you are correct. So 2 moles of oxygen are required. You will have to get a balanced equation to if it is written in the question complete combustion. So how does the complete combustion occur is because you need a balanced equation there. So how did this 2 come in? Because there are CH4. So you need here 2H2. So these becomes 2 moles of O and then again 2 moles of O. So we require 4 moles of O. So this is 2O2, twice of O2. So we require twice of O2 here. In the same sense, if we see here that these 1 mole of C7H13 basically requires, it came from balancing the equation. It came from that C7H13 requires 10.25 moles of O2 to get 7 moles of CO2 and 6.5 moles of H2O. I'll just do the balancing here once again for you. So C7H13 plus some moles of O2. Sorry. So this gives some moles of CO2 and some moles of H2O. Okay. So if there are C7 and we can say that to balance here we need 7 moles of CO2. Okay. Now H is 13 here. So how many moles do we need here? 13 by 2. Okay. So how many moles are coming up here of O2? So 13 by 2 O plus 7 into 2, 14. So 14 plus 6.5, which is 20.5. So if these are 20.5 moles of O, please note these are moles of O. So how many moles of O2 do you need? Half of this 20.5. So yes, 10.25. Sorry for the writing. So yeah, this is 10.25 moles of O2. So you get the balance equation here. And from this 10.25, you need to find out how many moles of N2 are required because it is given in the question air to fuel ratio. So you need that nitrogen also as well. So then you calculate the air to fuel ratio. Is it
Okay,
clear
ma'am.
now?
Clear, ma'am. Clear, ma'am. Thank you.
Yeah. Any other question? Anyone else with any question? So if there are no further questions, I will go ahead and close this session. I again ask you, are there any questions?
No, no questions, ma'am. Thank you.
No, it's okay. It's okay, ma'am.
Okay.
You give us a lot time. Okay, thank you.
Thank you.
Hmm.
Thank you for attending this session.
Thank
Thank you.
you.
Thank you, ma'am.